Hello viewer, my name is Hajile. Welcome back to the channel. I want to take you through integration by bats. Integration by bats. Remember, this is calculus 2, and normally the common problem to students. I want you to make you very easy about that subtopic. It's a very nice subtopic that needs just only your attention, nothing else. So let us start with a simple problems like if you have been given this function, integrate e raised to x dx. This is normally it will be a raised to x plus c. Doesn't change. Let's go to this. Integrate x e x square dx. Look at such function, and remember the way I've planned these examples is from simple to complex. So I'm starting with this complex one to get familiarize yourself with the calculus, whether to collect your thoughts, your minds. Come back to the channel and let us concentrate on this video. I'll take you to some of the examples, several examples, more than 20 examples in this subtopic of different views, geometrical, different kinds of examples with different style and the way they have been set in different papers. So have time and just follow me step by step. Don't skip even a video of any part because it's like a tied examples. You can't solve another example. Don't skip. It is good for you. You just follow me. Just even though I'm solving this simple one, I'm starting from simple to complex so that we get to familiarize yourself with the topic the way it is. So when you have been given such a function and you have been told you integrate, you are seeing here we have this part, we have just like two parts. We have x part and we have e raised to x squared dx, and that is the other part. When you look at this question very well, you are not supposed to solve by using integration by parts. Why? Because of x square. This x square now we normally substitute to the simplest form. We use substitution so that we make it into simplest form. So that when you come and say u is equals to x square, so let us find du. Du, remember, is a derivative of u. It is 2x dx. What have you realized? In our derivative, if we can rearrange it well, over 2 we get a half du is equivalent to x dx. In our function, we have x dx. In our function, we have x dx. This is it, x dx. So where there is x dx, we place a half du. Hope we are together. Let us do so. Integral of now e raised to, remember now x square is u, a half times a half du. What have we done? Now rearrange it proper. It will be derivative of a half e raised to u du. When you are in that form, now things are now starting to become very easy, because when you factor out the constant which is half, you remain with eu du. And you remember, when any integral of e raised to x or a to y is just the integral, it's just the same. So when you integrate e raised to u, it is just e raised to u, and you introduce constant. Let us now substitute. I have e raised to x square plus c. And that is the answer of that simple function when you have been given and you have been told to integrate. Let us look at another example. Let's say you have function like this. You have function like this, and you have been told to integrate. Look at it. It's just slightly different from the other one. This one has got x squared. That is why we use U substitution. But here it doesn't have x squared. So we use the normal formula of integration by parts. What is the formula? The formula goes like this. The formula states that we have in every function there must be two parts. There is this part and this part. So that is why the formula whereby we will introduce, there is something what we call u and there is something what we call v. Yeah, if the other part take u, the other part must also take v. And in most cases, v, when the other one is in derivative form, the other one is in integral form. Like in our case here, x, we can take x to be in a normal form, which is integral form, and now we cannot say, so he raised to 6x will take the second part which I've got dx, so we can say that is now dv instead of v, so we say dv. So there's something I want to try to make it here. For integration by parts there must be two parts, u and dv. So now if you want to find, because the formula goes like this, the integral of u dv, which is this one, u dv. So we want to integrate u dv. What is the formula? The formula itself goes like this. You say u phi, which is the function, minus the integral of v du. So you want to get the integral of u dv. You must first find the function, and then you less the integral of v du from it, so that you can get the integral of u dv. Hope we are together and hope we are moving on smoothly. Yeah. So this is the formula, use integration by parts. So I want just to tell you this question is solved by using integration by parts. And in integration by parts, there are two parts. There is mostly u and dv part. U and dv. And normally you take that part whereby when you differentiate it, it finishes, or when you differentiate it, it's get to 0 to 1. Like now in our case, u will be x. If we differentiate u, so now we want to find the u, it will be just, if you differentiate x, what do you get? 1. But you are not writing 1, you are writing dx. Hope you are getting, because you differentiate u with respect to the x. So, but there is 1 here, so that is always, you will always take that part whereby it is easy to differentiate. And now v dv, take the other part which is also in the integration form. It is in differential form. dv always is in the differential form. So you want to find v, because our formula, you can't use this formula unless you find v u v v du in all bars. That's why you should have u and du, phi, dv and phi. So if you want to find v, how do we do with dv? We integrate. It's not just like if you want to find du, you differentiate u, you get this one. If you want to find v, because it is dv, we integrate. But now look at here, this function. When you want to integrate e raised to 6x or e raised to constant times something, constant, so long as it starts with constant here, let's say 3x, 2x, you do what you call, you bring that constant to the denominator, you bring here, so it will be just like this, e raised to 6x, look at this one, e raised to 6x all over 6. Yeah, that is it. You should take it like that. There is no any other way I can explain behind that one. That is how it is. But if it was, let me find a paper somewhere. But if it was he raised to x, it remained to be he raised to x, because when you say if it is, let me show you why it is he raised to x. Why this one remains this one? Let me show you. Because let's say you have dv to be e raised to x dx, and you have been told find phi. How? Phi now will be just like that. Someone will ask me how. Let me show you. There is one here. When you bring that one down there, what is the effect? It just remain to be. That is why it is like this. I think I have explained it. Let us go back to the question. Have you seen? So we are finding phi. So in this question now, we are ready now to apply the formula. This part, let us apply this part so that we can get where we want, because we want derivative of u dv. We must solve this. So now in our case, let us substitute. U is x into v. V is 1 over 6. This is just like 1 over 6 e raised to 6x into bracket minus derivative of v. V now is 1 over 6 e raised to 6x, and du is just dx. Look at here. Let us solve it. So it will be x over 6 e raised to 6x minus, bring that 6 here. Is there anybody who is not getting why am I saying 1 over 36 e raised to 6x? Is there anybody whereby he or she doesn't know where the 6 come from? If there is someone, let us go back to this video and see how I explain it. Skip the video. So look at this, and then you introduce the constant. That is all about it. And that is all about it. And that's the answer. That's the answer, by the way. So that is how simple it was. We shall go step by step, so many examples as much as possible, so that you people can get exactly what is it. Let us go to number 4. Yeah. Number 4 now, we want now to do what we call ask for that trigonometric function, but the formula, just only the formula will remain the same. You have been given such a function, and you have been told to integrate. Look at That's two sides. Of course, this is u and this side is dv. So we have u to be x. So du will be just derivative, the differentiate this one, it will be dx. Now dv, we have dv to be sin x dx. So v is equivalent to here. Now what happened when you differentiate sign? What happened when you integrate sign? Look at this. When you integrate sign, because here now we have to integrate to get v. When you integrate sign, you get negative cos x. This is now negative cos x. Look at there. Come here. Write down the formula now. The integral of u dv is equivalent to u phi minus integral of phi du, and that is simple like that. Let us apply this part so that we can get the one we want. So v u phi, because already we have it, x into negative cos x minus integral of v, which is negative cos x du is just dx. That is all about it. Look at here. And there's something I want you to explain. Let me go back to this video. Someone might ask me where these dx have gone. Why I didn't see you integrating this dx. When you see integral and you have here dx, what does come in your mind? You differentiate this dx so that you come to integral. Integral of dx, you differentiate that dx so that you get. So you differentiate this one. When you differentiate, but you integrate this one. I'm telling you, it is just only two functions. In a function, there must be two parts: the first part and the second part. So this is so what was it? The formula was, so when you integrate this one, you differentiate this one. I think most of the teachers are not explaining this, but here I will have to explain to you. When you differentiate, even if there is this integral, you integrate this one, you differentiate this one so that it will finish. When you differentiate this one, it will be just 0 or 1. It's just 1. When you differentiate this one, it will be 1. That's why it is finished. But integrate this one, differentiate this one. Come here. And it's just like that. I wanted to make something clarified well so that people not get confused. I don't want people now getting confused because of such a thing. So let us get here. Let us factor out negative here. It will be now negative, it will be plus. Integral of cos x dx. So negative x cos x plus, when you integrate cos x, it will be just simply sin x. When you integrate this one, differentiate this one, it will be 1. Now plus e. That is okay. That is all about it. And that one is this one is here. And we cannot write that one. We write c. I cannot write that one. We write c. Hope you guys, we are going on well. And if there is any question, you ask me in your comment section. Yeah, let's continue. Number 5, I want you to take you in a simplest way whereby no one will never understand. Even the person who haven't attended the calculus class will have an opportunity to solve the equations on calculus. Look at that question. That's two parts again. This is u part and this is dv part. That is all. When you write this just like that, the formula now will be very easy for you. So long as you have known that this function is, I can integrate it by use of integration by parts. So let us, u will be x, du now will be definitely dx. Yeah, because it will finish. So we have now dv to be e raised to 2x. I'm seeing which is dx because it is the whole of the remaining part. Now we let us get phi. Phi is what do you go do with this one? You integrate this one. You integrate this one, you will get, you bring these two down there, it will be x, 2x all over 2. Yeah, that is it. And that it will be remain just like that. I told you earlier. What about when you integrate this one and it's finished? Because when you integrate this one, you differentiate this one, it will be 1 times this one. It is just that number, it is just like that. So we have phi. Phi in a simplest form will be now half e raised to x. So now we have everything. Let us write the formula. Don't be tired of writing. U dv is equals to integral of u phi minus integral of v du. Look at integral of u dv, you interchange. Integral of u dv, it will be the function minus the integral of phi du, interchange. I hope you are looking. That's how to grab the formula, by the way. U phi x into phi. Where is phi? V is a half 2x minus integral of v. Phi is a half where is du? Du is dx. Look at here. This question is just simple like this, and then you open the bracket, and that is all about it. And minus, so now we come here. You come here. Integrate integral of this one. You integrate this one. You differentiate this one. That is all about it. So you come to integrate this one. What do I tell you? You continue integrating. You bring that 2 to there, so it will be 1 over 2 times 2 because there is 2 another one, and then there is, so you say e raised to x, just like that. So when you integrate this one, it is 1 times 1, it is like finish, plus that c, which is 1. And that's all about it. So can you finish it? Half x e raised to x minus 1 over 4 because 2 times 2 is e raised to x plus c. Guys, I hope it's simple like that and you're getting it, because I don't want you to be left behind. That is all about that part. Let us go to next part. You guys, it's very simple like that. If you follow step by step, nothing is very hard. It is very simple. Let us look at what example 5. Let us look at example 6. Example 6, what does it say? I want you now to introduce you to something. In example 6, there is something I want you to introduce you with. There is something I want you to introduce you with. You will realize that there are some of the function whereby you need to integrate more than one, because you find that, unless in our formula, let me write the formula first. The integral of u dv is equivalent to u phi minus the integral of v du. Unless now this du remain 1, you will have to reintegrate. You will have to reintegrate. Yeah, as much as possible, unless du remain 1. Hope you are getting me. Unless du remain 1, you will have to reintegrate. You reapply the formula. This is integration by parts formula until you get du to be 1. Guy, I'm using the simplest way now. Teacher will use such things just only for you to understand. And I hope this is not the right way I could have teach you with, because some of the people will say you have used just the simple way. This just I like it to use a simple way everyone can understand. So I've always say when you see this function, integration by parts, there must be 2 parts. Just the way by parts use. Listen, there must be 2 parts. This is u side and the v side. Yeah. So u side is x square. Du now will be 2x dx. Look at something. This question you will have to do more than 1. Why? Because the u is not ending with 1. You see, they still have got a variable x. If we could have ended with 2, it is just okay, but it still have got variable x. So it means we shall do more than 1. Even the u itself is enough for you to tell you that this thing will do more than 1. Guys, let us do the first one. So let us do dv now will be dv will be e raised to 3x dx. Now look at the phi will be, we have dv, phi will be you because of dx, so it is in integral form. To get phi, it is in differentiation form. To get now phi, you integrate it. So, and I tell you, when you integrate such thing, I don't want to tell you, you see the way I'm doing, you bring that 3 here, it's just like that. Yeah, I said that. You look what I've done. I bring this 3 here down, and then even if I want to reintegrate this one, I just bring these 3 here, it will be 9. If I want to reintegrate it. So let us apply the formula. We have all of them. Let us apply this side. U phi will be x square into phi will be 1 over 3 now e raised to 3x minus now the integral of phi. Phi will be 1 over 3 e raised to 3x. Du will be 2x dx. Look at that. The question is just like that. Let us finish this side first, because I see this side does not any problem. That side to be in that side, but the other side is where the problem. Integral of, so you come and say integral of this. If you see well, the integral of this one, we want something. Yes, we can integrate this one very well. We can integrate this part, because it has this part, the differential part and integral part. We can integrate this one and we get well, but this one will not finished. So we have now to do, we reintegrate. We apply another u to be 2x and du to be, look at here, this is where now I want people to be very keen. Du it will finish now. It will be now just simply what? Just simply 2 dx. Let's see. 1 here, it will be 1 minus 1, which is 0. So it will just simply 2 dx. Just is how it is. It will be simply just 2 dx. 2 dx now. that is du. We have 2 dx. We have now dv to be, dv is which side of dv in this form. If you have take u to be the 2x, dv definitely will be, we have take to be 2x. The remaining is 1 over 3 e raised to 3x, e raised to 3x dx, because of this dx. So now we can find v. V will be, this is in differential form. To get v, you do what? You integrate this one. When you integrate this one, you do what? You say 1 over 3 dot 3 e raised to 3x. I'm bringing these 3 to down here, and I join to these 3 so that I get v. V will be e raised to 3x all over 9. I don't want you to get confused. That is why I'm going slowly by slowly. So let us apply the formula. Let us apply this for the formula. Again, uv will be, or let us write uv will be u now will be 2x, v will be e raised over 9 minus, now the integral now of v, new v is 1 over 9 e raised to 3x, du is just 2 dx. That is all about it. Let us do it bad. So 2x over 9 e raised to 3x. Where was this x? Oh yeah, this x into x. Integral of this one to be now 3 times 9, so it will be 1 over 27 e raised to 3x. I hope now people are now know where 27 is coming from. What happened to when you integrate this one? The x will go, you will remain with 2. What do you do now? Plus c, because we are saying we remain with 1, remain with 2 this time down. So it will be 2 over 9 x e 3x minus, it will be 2 over 27 now, because when you do times e raised to 3x plus c. This is now the first answer, but we have here minus. We bring this one here. We bring that one here, minus x square over 3 e raised to 3x. What are you seeing here? Is there any like them? No. Or is it? No. It's just like that. The answer is just like that. That is it. Hope you guys are getting. This was now the one of the function. You must use integration by parts for the first and the second time. You integrate it first and you integrate for the second time. We shall do such question. There is such question so that people will get well how to solve this one. Follow this well and you will know how the things goes. You see, we do it function, this function here. The first function was just here. As we are heading to calculate it, we realize that here dx it won't finished, because we want either whole number 2 or 1. So we had now to do again what we call differentiation. We had to do we had to integrate this alone again. We find it, and we come through. We find it here. That was the whole answer. Now we connect with the main one and we get the answer. And that is all about it. Hope you are following, guys. Let us go to number 7. I want you to, we go step by step. We don't rush. Don't want rushing. The integral of x square e raised to x dx. So this is integration by parts. As the question suggests, integration by parts, there must be two parts, u side and dv side. Take u to be x square, so du now will be, remember when you are finding du, you differentiate u, and you know to differentiate it. I don't want to teach you. What have you realized with this again? It's just like the same question. That is why I tied this question in this one, so that if you didn't get in this one, you get in this one. So now it will be now, so let us find the v. The v is equivalent to, the other side of the function. It will be e raised to x dx. So let us find phi. V will be just e raised to x. What did I tell you? There is 1 here over 1 here. It's just e raised to x. I have explained how that e raised to x will remain to be e raised to x, whether it is integration or differentiation. I have explained it. Let me explain. I have explained it before, and I can even repeat to explain it. Let me repeat it. When you have dv to be e raised to x dx, and you have been told find phi, definitely what you will do, you'll do what? You integrate. So let us try to integrate this one. Let's assume we have 1 here. This is feasible. And I told you, when you have the constant here, we bring that constant over here. So when you bring that constant over here, it just remains to be 1 over 1, and there's no need of writing 1 over 1. You just write e raised to x. That is why e x derivative of it will just only be e raised to x. Hope you are getting, guys. Now let us continue with the question we were solving. The question was, so have you realized something here? Hope those people who are following the first question have now get to, there is something also with this question. We shall integrate twice. Yeah, let us solve it. So we have everything. Let us write the formula. The integral of u dv is equivalent to u phi minus the integral of v du. Now let us substitute the formula. Use this part, because that is the part we are interested in. So uv is just like, we have u to be x square, and we have v to be, where is v? E raised to x, minus the integral of v. Where is v? V is raised du. We have to do x dx. So now you guys, look at here. I told you, unless du is 1, there's no way you can end this integral. So we have to redo it again. So u will be 2. We take our new u to be 2x. So now we get du to be now 2 dx. Are you seeing it? Yeah. So, and when you have so now we shall have dv to be the other part. dv will be e raised to x dx. So v will be e raised to x. So let us substitute by using the formula formula of integration by parts. This formula, our u will be 2x into our v is e raised to x minus the integral of v is ex du is just simply 2 dx. Now let us do 2x e raised to x minus The integral of this one, I've told you to remain to be just like that. E raised dx. The integral of 2 dx. So it is not the integral of 2 dx. When you integrate this one, the second part you must differentiate according to the formula. The second part you must differentiate. So let us differentiate this one. It will be just 2. Remain 2 plus c. So how is that? Yeah, rearrange things. It will be 2x e 2x e 2x minus this one times this one, it will be 2ex plus c. Remember there was this one, you bring it down here from the main one. You know we integrate twice, so there was this one from the main minus, and you remember that there was that one, so it will be like x square e raised to x. You try on your own and see whether you will get the same. That is the answer. Hope we have understand very well. This is integration by parts more than ons. Let us go to another another question. Number 8. What does number 8 read? The integral of ln x all over x cube. This question, there is 2 parts. But first, let us rearrange it to be in an order form. This is just like equivalent to x cube. So when you bring this x cube to the numerator, sign will change of the power. Ln x. This is u and this is dv. That is it all about this. You find the x of it. So u will be x negative 3. Du now will be, remember, du is the derivative of u. So you minus 1 here. You minus 1 here and we bring that so it will be minus 4. So we'll say you bring that whatever you have done here, whatever you have got here, you bring it here. So it will be negative 4 x raised to negative 4 d what? Dx. Hope you are getting. So let us find du. Dv is just ln x. No. Sorry. There's something I want to explain you guys. There's something I want to explain to you. The way we have rewrite this equation, let's say it was ln x all over x cube. This is where I go wrong somewhere, just a bit, but I'm sorry. I'll rectify it. So even you'll go wrong in exam, so these are the common mistakes that normally happen. So look at here. When you rearrange this function, it will look like this: ln x, let's say ln x negative 3. So when you look at this negative, when you apply the power rule or the when you apply the when you differentiate this one, it is so much difficult. Rather than when you have u to be ln x and you say du is just 1 over x, which one is very easy? Because derivative, because when derivative of ln x is 1 over x. Hope you are seeing such things. So that we'll get now dv to be x negative 3 dx. So now, so that we get phi to be, we integrate this one. And how do we integrate? You remember very well the way we are integrating. When you have something like this and you want to integrate this one, it will be now x n plus 1 all over n plus 1. I think it was just like that. Let us integrate that one in that form. So we shall say plus 1, and whatever we have got here, divided by negative 3 plus 1. So it will be dv is just x negative 3 dx, because we have made it here to be that, so it will not be feasible. Let us use this one. But we have known and negative 3 plus 1 is just negative 2, so x negative 2 all over negative 2, yeah. So if we simply rearrange, it will be negative 2x per negative 2, yeah. This is our phi. So let us use the formula. The integral of u dv is equal to u phi minus integral of v du. I think it is so. Yeah, let us find u. U is ln x. V is we have here to be negative half x minus integral of v. V is negative half times du. We have du to be 1 over x dx. So look at here. We want to go step by step. ln x into bracket, also you can say half negative half x negative just like that, minus integral. Let us do the integral of this. Integral of all of this. How do we integrate such thing with this? This is the formula. Plus 1 plus 1. This is plus 1. And you say now plus 1 here. So it will be. So now when you plus 1 in this form, it will be just like 1. It will remain with negative 1. So it will be just x negative 1. Then now you come down here, you say there was negative, here was negative, there was negative 2, now plus 1 again. It will be just negative 1. It will be just negative 1. So negative 1 over negative. So when you finish like this, so it will be 1 over x. Let me just let us arrange this first, because those negatives are very complicated. So here we shall have negative x all over negative 1 times 1 over x. So it will look like this one will finish, and this one is like 1 over x. This one is just like 1 over x. Yeah, this one is just like 1 over x. It's just like that. So when you times all of it, it will be 1 over x square. So when you have such thing, and you have, remember, it was inside the negative. It was inside the negative, so it will be negative. So it will be negative here. So we'll have this one ln x into, we have this one, so we can decide to bring this x down here so that we eliminate this negative. We bring it down here and then minus 1 over x square. That is the answer. I think so. Let me confirm for you because I have the solution. I have the solution. I have the solution here so that you cannot do things which is not bringing sense. Yeah, we have here positive. We have here positive. Do you know why we have here positive? Because there was negative here and there is this negative, so it is positive here. That plus c. That's the answer. Hope guys you are following. Though it was somewhat complicated because of such question, but you are seeing we are trying as much as possible to I'm trying as much as possible to explain everything which is inside there so that you don't be in a dark place. So there is one more question. There's 2 to 3 questions I have to explain. Let us I'm feel tired. I should rest. Let us see this one. There is this question: 3t plus 5 cos into t plus 4. This is another complicated question. If you don't follow well, slight mistake will make everything difficult. So this is, we have u side and v side, u side and v side. That is always just like that. I want you to know that dt, it is just dt because of this. Look at here. Look at here. We have so we have u to be 3d. You can even post a video and try on your own because so far you have got what you are doing here. Du is just 3 dt. Because if you is there anybody who doesn't know how to differentiate this one up to this far? I can't think so, but if there is one, let me know from the comment section. I can do video on the same. So we have u and the v. So we have, let us have the v to be cos t over 4. Here now is a place whereby you people want you to begin. It's always challenging part. That's why I select these questions wisely. dt. So now v is, look at here, the integral of this, so that you can get v. You bring this for here and then you change the sign. What is the integral of cos? The integral of cos is sine t over 4. That is it. I hope guys you get what I've said. The integral of this, you bring this for here, whether it was 5, 3, you bring it here, then you change the sign of this one, and it's just like that. I think let us now apply the formula. The integral of u dv is equal to u phi minus the integral of phi du. Let us substitute this one. U phi is just 3t plus 5 into phi. Phi is 1 sine t over 4. This is minus the integral of v is 4 sine t over 4 du is just 3 dt. So let us do this part first, the second part, because the second part is always challenging. So let us do this. The integral, so when you integrate this one again, this one, t over 4, when you integrate, you remember, when you integrate t over 4 again, it will take 4 that side because of this integration. So the integration to finish, you take 4 till you now 16, integral of sine x, it will be negative cos x. So it will be negative cos t over 4. You could have taken, sorry, so it will be negative 16 cos t over 4. The integral of, so when you integrate this one, you differentiate this one, it will be 3 times 3. So when you times plus c, I mean, when you times with 3, you get negative 48 cos t over 4 plus c, and you remember you have the whole of this, we bring it here, so it will be now 3t plus 5, we have 4 here, sine t over 4 minus into bracket minus 48 cos t over 4 plus c. This one will be 12t plus 20 sine t over 4 plus 48 cos t over 4 plus c. Let me confirm the answer because I don't want to do things. People were not seeing it. I'm sorry. Remember, I bring this to all of this part. I do this part, this u phi is just this part. Integral of phi du is just from here. Integral of phi du is this part up to here. And then I bring this one, I connect it here, and it's just like this. Because let me confirm the solution, because I don't want to give you things which are very wrong. I want you to have a clear answers on the same. Yeah, the answer is just like that. Hope guys you have got and you know how to solve it. So you go and do more vision of the same. Go and repeat these questions on your own. Try to analyze it on your own and see how whether you have catch it or you haven't. Because this is the most important part when it comes to calculus 2. Yeah, I'll do more visuals on the other subtopics. You come to the channel and you find it there. Let us have the last part here of a graphic solution. The last question. Let us try this. The last question is not hard as such. The integral of just like this, and we have the limits for the 0. So it's just like the same, not because the limits has been introduced it looks something different. No, this is to remain to be u, this will remain to be dv. So u will be x. Now du, now you get simply dx. Now we have dv to be e. Remember now there is something here. I want you to give you something here, dx. So v is equal to Remember what did I tell you about this one? You bring any constant here to come down here, so it will be over. So when you want to find phi, it will be e ax over negative 1. So simply v is negative e raised to negative x. I hope you are seeing this thing. I say that when you integrate this one, you bring constant down here, and we have constant to be negative 1. We have brought it here, and we rewrite in a good manner. It's just like that. Let us substitute. So we know the formula u dv is equal to the integral of u phi integral of phi du. So let us find uv x into v. V is just negative e is the ex into bracket minus integral of v is negative e du is just dx. So when you are here, it will be now what? E raised, you open the bracket, e raised x, put x here, minus, when you open it will be plus, before anything, before you put, let us put minus into bracket. You see here, when you integrate this one again, it will be, when you integrate this one, then we have another paper. I want to put, I've said, when you integrate this thing, it will be now, it will be now like this all over. You bring this constant one here, negative 1. What are you realizing? So it will be e raised to x. When you integrate dx is just 1, so it is just plus c. But we cannot plus it because we have the limit. So we can say e minus, now we open the bracket, and now you have the limits for 0. Let us try to replace it. I will try to copy that question here because that is the end of the page. Minus e negative x limits for 0. Let us replace. Where there is x, we place with 4. It will be now negative e 4 minus e 4 minus, replace with 0, negative e 0 minus e 0. And let us do. Don't skip. Don't say this is a very simple. You substitute in a very funny way. You will not get the answer. Let us go step by step. I have the same denominator and the same numerator. It will be negative 5 e raised to 4. Then negative, how do we write? Negative 5 how is this negative 5? Oh yeah, because there was an x here. So we put 4 here. Negative 5, so it will be 4 plus 1 here. So it will be 4 plus 1. Yes, that 4 plus 1 because I have the same powers and the same base. So 4 plus 1, I know I have negative, so it will be total of negative 5 e raised to negative 4 minus into bracket a number raised to 0. A number raised to 0 is just because here we have here we have 4. We have 4 here. So you can say a number raised to 0 is just 0. It's just 1. So 1 minus a number raised to 0 e raised to 0 is just 0. Here is just 1. So we say, come and say, it's the way we mess up. We mess up this thing. Here. So we mess up. This. We didn't substitute the way necessary. Yeah. This is now, when you get here, it is 1 and here it is 0. So when you do your own mathematics, it will look like this. It will look like this minus 1 because just like that, and that is the answer. Try on your own and see whether you will get that answer. That is the right answer for that, please. And guys, until next time, let us meet on the next video, and please subscribe, comment, and let me know your view. Goodbye.